we are. I thought I should do a couple examples from the worksheet. So here's a few examples for you to get started. The first step is we're going to solve it. So it says sine of x, so I'm going to subtract 1. And I get 2 sine of x equals -1. Divide by 2 divided by 2. And so we end up with the equation sine of x equals -1/2. Now to find out where that is, we go to our unit circle. And on there we know that the sign are the y values. And so we're looking for values that are at -1/2. So right on here is a -1/2 on our unit circle. So I know that it's going to be there and there are the two values that give me that. So this is 7 pi over 6, and this one is 11 pi over 6. Just looking at my unit circle. Same dealio as the last one, except for this one has a squared in it, and I thought we should do one of those to make sure you understand how to do the squaring ones. Divide by 2, divide by 2, and I get the sine squared of x is equal to a half. Well, to get sine by itself, we have to square root. But when you square root an equation, you get plus or minus. And the top square rooted is 1, bottom square rooted is a half. If I rationalize that, I end up with plus or minus square root of 2 over 2. Well, I know where that is if I go to my unit circle again. We know that over here the sign is the y value at that place, and then here's the -1 over here, and there's a -1 over there. Well, they happen to be at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Same kind of question here with the tangent. Solve it. I get tangent equals 1 or -1 when I subtract the 1 over the square root of 3. Rationalize, I get -3 over 3. And again, we go to our unit circle. And we know that all students take calculus. So I know that the tangent is positive here. It's going to be negative here, and we're looking for the negative ones. The tangent's going to be positive here and negative there. So I know that at this angle and at that angle, we're going to have -√3 over 3. Well, this one happens to be at 5 pi over 6, and this one happens to be at 11 pi over 6. Now there's this third type of problem, because we've talked about ones where we just solve and we get our answer, and then we talked about the one where we have a squared thing and we have to solve and square root. Here it looks like a trinomial, and when I factor it, I get 2 sine x and sine of x, and I'm going to have a 2 here and a 1 here, and they both have to be negative. Outside, outside gives me -4, inside, inside gives me -1, and that makes -5. So I'm going to set both of these equal to 0. And sine of x equals to 2. This is an extraneous root because we know our sine graph oscillates between 1 and -1, so it's never going to get to 2, so this is no solution. And over here, if I added 1 to both sides and then divide by 2, we get the sine of x is equal to 1/2. Remember, sine is the y values. So we're looking at the values that are 1/2, so there, and that happens at pi over 6 and 5 pi over 6. Here's another factoring one, just kind of like the previous one, but a little bit different. So let's factor this into sine of x and sine of x. And then I'm going to go with a -3 and a +1. And again, we know that the sine is not defined, so this is a no solution. And we also know where the sine is equal to -1. Sine is equal to the y value. The y value is -1 at 3 pi over 2. So there was a possibility of having 4 answers. When you have a squared term, there's a possibility of 4 answers, but yet we only got 1 solution. And the last one on this video is the sine of x is equal to the tangent. This one's a little different than the previous ones because they ask us to find where the sine is equal to the tangent, and I don't know where that's true. So some of the things that I can do here is do a little manipulation by subtracting tangent to get it equal to 0. And then I'm going to change that into sine over cosine, get a common denominator. And I notice that I can get a tangent out of there and a tangent out of there. So I'm going to take a tangent, and I'm left with a cosine -1. This is good because I have the product there, and I know that either the tangent is equal to 0 or the cosine of x -1 is equal to 0. Or my tangent is at 0, and notice that it doesn't give me a 0 to 2 pi here. You know, if it was a 0 to pi, there'd be 1, but I'm going to go with 0 and pi because it doesn't really tell me which one's inclusive, either the 0 or the 2 pi, where the tangent's equal to 0. And the cosine is equal to 1. And if I go to my unit circle, we know that the cosine is equal to 1. Cosine is the x value, and that happens at 0 also. So those are the values that work. I also wanted to look at this one other way. I wanted to look at it if I take it at this point, which if we want to avoid using the tangent, we get this equals 0, multiply both sides by cosine, and I end up with the cosine of x times the sine of x minus the sine of x equals 0. Factor out that sine of x, and I get cosine x minus 1. And I know this isn't hardly any different than the previous one, except for the fact that here I only have sine and cosine. In the previous one I did have a tangent. And so people, to answer that one, would have to know more about the tangent. In this case, the sine of x is equal to 0, and the cosine of x equals 1. I think that part stayed the same. Well, the sine of x is equal to 0. If we go, we know that we hit 0 and at pi, and that was the same places that the tangent, because sine is the numerator for tangent. So it ended up being the same answers, but in this case I only used sine and cosine. In the previous one I used tangent. There we go. I think that's as far as I get in this video.